A Siemens combination arc fault circuit interrupter, or AFCI, provides protection from both arc faults and ground faults. It meets the requirements of the 2020 National Electrical Code, often referred to as the NEC. It is designed to be easy to install and use, and it features a compact design. An arc fault is an unintentional electrical discharge that occurs when electricity jumps between two or more conductors. Arc faults can generate a lot of heat and can easily start fires. Ground faults occur when electricity flows from a live conductor to ground. Ground faults can also cause fires and can also cause electrical shock. The 2020 National Electrical Code, or NEC, requires that all new residential electrical circuits be protected by combination AFCIs. Combination AFCIs are designed to detect both arc faults and ground faults and to interrupt the circuit when neither type of fault is detected. This helps to protect people and property from fire and electrical shock. The Siemens combination AFCI is designed to be easy to install and use. It features a compact design that makes it easy to fit into electrical panels. It also features clear markings and easy-to-follow instructions. To understand the features and benefits better, it's helpful to delve deeper into arc faults and ground faults, and how AFCIs work. Let's start with arc faults. There are three main types of arc faults. Firstly, series arc faults. Secondly, parallel arc faults. And thirdly, ground arc faults. Series arc faults occur when there is a break in a single conductor. This can happen when a wire is damaged, loose, or corroded. The electricity has to jump across the gap, creating an arc. A common example is a frayed extension cord where the internal wires are broken. Parallel arc faults occur when there is a short circuit between two conductors. This can happen when the insulation on two wires is damaged, allowing the wires to come into contact. This creates a low resistance path for the electricity to flow, resulting in a high current arc. A common example is a nail or screw driven through electrical wiring in a wall. Ground arc faults occur when there is a short circuit between a conductor and ground. This can happen when the insulation on a wire is damaged, allowing the wire to come into contact with a grounded object, such as a metal pipe or an appliance chassis. This again creates a low resistance path for the electricity to flow, resulting in a high current arc. All of these types of arc faults can generate intense heat. This heat can ignite nearby materials such as wood, paper, or fabric, and start a fire. AFCIs are designed to detect these dangerous arc faults and quickly shut off the circuit to prevent a fire. Now let's talk about ground faults. A ground fault occurs when electricity unintentionally flows from a live conductor to ground. This typically happens when the insulation on a wire fails, allowing the conductor to come into contact with a grounded surface, such as a metal enclosure or a water pipe. When a ground fault occurs, the electricity takes the path of least resistance back to the source, which is usually the electrical panel. This can result in a large amount of current flowing through the ground path. This high current can cause several problems, including electrical shock, equipment damage, and fire. A person who comes into contact with a grounded object while a ground fault is occurring can receive a severe or even fatal electrical shock. The high current can also damage electrical equipment and appliances connected to the circuit. Additionally, the heat generated by the ground fault current can ignite nearby materials and start a fire. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock by detecting ground faults and quickly shutting off the circuit. They work by monitoring the current flowing to and from an appliance or circuit. If there is a difference of even a few milliamps between the incoming and outgoing current, it indicates that some of the current is leaking to ground. The GFCI will then trip, cutting off the power and preventing electrical shock. Combination AFCIs offer both arc fault and ground fault protection in a single device. This is important because both types of faults can cause fires and electrical shock. The 2020 National Electrical Code, or NEC, mandates the use of combination AFCIs in many residential circuits, including those that serve bedrooms, living rooms, dining rooms, and kitchens. This requirement is intended to provide a higher level of safety for occupants by protecting against both arc faults and ground faults. The easy installation and compact design of the Siemens combination AFCI make it a convenient choice for electricians and homeowners. The devices are designed to fit into standard electrical panels and are easy to wire. Clear markings and instructions further simplify the installation process. In summary, the Siemens combination AFCI provides comprehensive protection against arc faults and ground faults, meets the requirements of the 2020 NEC, is easy to install and use, and features a compact design. It is an important safety device that can help to protect people and property from fire and electrical shock. Remember to always consult with a qualified electrician when installing or working with electrical equipment. Electrical work can be dangerous, and it is important to follow all safety precautions. Consider these additional points about AFCIs and GFCIs. AFCIs and GFCIs are designed to protect people and property from electrical hazards. However, they are not a substitute for safe electrical practices. It is still important to follow all electrical safety precautions, such as never overloading circuits, using extension cords properly, and keeping electrical equipment away from water. AFCIs and GFCIs should be tested regularly to ensure that they are working properly. Most AFCIs and GFCIs have a test button that can be used to verify their functionality. If an AFCI or GFCI trips frequently, it may indicate a problem with the electrical circuit or appliance. In this case, it is important to consult with a qualified electrician to diagnose and repair the problem. AFCIs and GFCIs are an important part of a comprehensive electrical safety plan. By using these devices and following safe electrical practices, you can help to protect yourself and your family from electrical hazards. Let's delve further into the specific technical aspects of how combination AFCIs detect and respond to arc faults. They utilize sophisticated electronic circuitry to analyze the characteristics of the electrical current flowing through the circuit. They are designed to differentiate between normal operating currents and the unique signatures of arc faults. One key aspect of arc fault detection is analyzing the current waveform. Normal electrical current typically has a smooth, sinusoidal waveform. However, arc faults create erratic and unpredictable current patterns, often characterized by sudden spikes, high-frequency noise, and distorted waveforms. The AFCI's internal microprocessor constantly monitors the current waveform and compares it to pre-programmed parameters that define the characteristics of an arc fault. Another technique used in arc fault detection is analyzing the frequency spectrum of the current. Arc faults generate a wide range of frequencies, including high-frequency components that are not typically present in normal electrical current. The AFCI uses filters and signal processing techniques to isolate and analyze these high-frequency components. If the AFCI detects current patterns or frequency signatures that match the characteristics of an arc fault, it will quickly trip the circuit, interrupting the flow of electricity and preventing a potential fire. The tripping time is typically very short, on the order of milliseconds, to minimize the risk of ignition. Now let's look closer at how a combination of AFCIs detect and respond to ground faults. As mentioned earlier, GFCIs, which are integrated into combination AFCIs, work by monitoring the current balance between the hot and neutral conductors. In a properly functioning circuit, the current flowing through the hot conductor should be equal to the current flowing back through the neutral conductor. However, if a ground fault occurs, some of the current will leak to ground, creating an imbalance between the hot and neutral conductors. The GFCI continuously monitors this current balance using a differential transformer. The hot and neutral conductors are wrapped around the transformer core. If the currents are equal, the magnetic fields created by the conductors cancel each other out, and no current flows in the transformer's secondary winding. However, if there is a current imbalance due to ground fault, the magnetic fields will not cancel out completely, and a current will be induced in the secondary winding. This induced current is detected by the GFCI's internal circuitry, which then trips the circuit, cutting off the power and preventing electrical shock. GFCIs are extremely sensitive and can detect very small current imbalances, typically on the order of 5 milliamps. This high sensitivity allows them to provide effective protection against electrical shock. It's important to understand the difference between AFCIs and GFCIs. AFCIs protect against fires caused by arc faults, while GFCIs protect against electrical shock caused by ground faults. Combination AFCIs provide both of these protections in a single device. Here are some key considerations when selecting and installing combination AFCIs. Firstly, ensure that the AFCI is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. This indicates that the device has been tested and certified to meet safety standards. Secondly, select the appropriate AFCI for the specific circuit application. AFCIs are available in different current ratings and with different tripping characteristics. Thirdly, follow the manufacturer's instructions carefully when installing the AFCI. Improper installation can compromise the device's effectiveness and create a safety hazard. Fourthly, test the AFCI regularly using the test button to ensure that it is functioning properly. If the AFCI does not trip when the test button is pressed, it should be replaced immediately. Fifthly, if an AFCI trips frequently, investigate the cause of the tripping. Frequent tripping may indicate a problem with the electrical circuit or appliance. Consult with a qualified electrician to diagnose and repair the problem. Let's discuss the NEC requirements related to AFCIs in more detail. The 2020 National Electrical Code, or NEC, Section 210.12 requires arc fault circuit interrupter protection for branch circuits that supply dwelling units. Specifically, the following locations require AFCI protection. Firstly, all 120-volt, single-phase, 15 and 20 amp branch circuit supplying outlets or devices installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, and similar rooms or areas. Secondly, branch circuits that supply outlets or devices in dormitory units. The NEC also includes exceptions to these requirements. For example, AFCI protection is not required for circuits that supply only a fire alarm system or a smoke detector system. It is important to consult the NEC for the specific requirements in your area. In addition to the NEC requirements, many local jurisdictions have their own electrical codes that may require additional AFCI protection. It is important to check with your local building department to determine the specific requirements in your area. When replacing an existing circuit breaker with an AFCI, it is important to ensure that the AFCI is compatible with the electrical panel. AFCIs are available in different sizes and configurations. Choose an AFCI that is designed to fit into the existing panel. It is also important to ensure that the AFCI has the same current rating as the circuit breaker that it is replacing. Using an AFCI with a higher current rating can overload the circuit and create a fire hazard. When wiring an AFCI, follow the manufacturer's instructions carefully. AFCIs typically have a hot wire connection, a neutral wire connection, and a ground wire connection. Ensure that the wires are connected to the correct terminals. Improper wiring can damage the AFCI and create a safety hazard. After installing an AFCI, test it using the test button. The AFCI should trip immediately when the test button is pressed. If the AFCI does not trip, it should be replaced immediately. AFCIs are an important safety device that can help to protect people and property from fire and electrical shock. By understanding how AFCIs work, following the NEC requirements, and installing AFCIs properly, you can help to ensure the safety of your home or building. Here's a breakdown of troubleshooting common AFCI tripping issues. Nuisance tripping is when an AFCI trips for no apparent reason. This can be frustrating and inconvenient, but it is important to investigate the cause of the tripping. One common cause of nuisance tripping is electrical noise on the circuit. Electrical noise can be generated by various sources, such as electronic devices, appliances, and lighting fixtures. If electrical noise is suspected, try turning off or unplugging these devices one at a time to see if the tripping stops. Another possible cause of nuisance tripping is a loose or corroded connection in the circuit. Inspect all of the connections in the circuit, including the connections at the AFCI, the outlets, and the appliances. Tighten any loose connections and clean any corroded connections. Sometimes a faulty appliance can cause an AFCI to trip. If you suspect that an appliance is causing the tripping, try unplugging it and see if the tripping stops. If the tripping stops, the appliance should be repaired or replaced. In some cases, nuisance tripping can be caused by a faulty AFCI. If you have tried all of the other troubleshooting steps and the AFCI is still tripping, it may need to be replaced. If an AFCI trips and stays tripped, it indicates that there is a fault in the circuit. The fault could be an arc fault, a ground fault, or a short circuit. The first step is to try resetting the AFCI. If the AFCI trips again immediately after being reset, it indicates that the fault is still present. In this case, it is important to investigate the cause of the fault. Check the circuit for any signs of damage, such as frayed wires, loose connections, or burnt outlets. If you find any damage, repair it immediately. If you cannot find any obvious signs of damage, you may need to call a qualified electrician to diagnose and repair the fault. It is important to never ignore a tripped AFCI. A tripped AFCI indicates that there is a problem with the electrical circuit. Ignoring a tripped AFCI can put you and your family at risk of fire and electrical shock. Here are some additional tips for preventing AFCI tripping. Firstly, avoid overloading circuits. Overloading a circuit can cause the AFCI to trip. Secondly, use extension cords properly. Do not use extension cords as a permanent wiring solution. Thirdly, keep electrical equipment away from water. Water can cause electrical shorts and ground faults, which can cause the AFCI to trip. Fourthly, inspect electrical cords and plugs regularly for damage. Damaged cords and plugs can cause arc faults and ground faults, which can cause the AFCI to trip. Fifthly, do not run electrical cords under rugs or furniture. This can damage the cords and create a fire hazard. Lastly, be careful when using power tools. Power tools can generate electrical noise, which can cause the AFCI to trip. By following these tips, you can help to prevent AFCI tripping and ensure the safety of your home or building. Remember, electrical safety is paramount, and consulting a qualified electrician is always recommended for any electrical work or troubleshooting.